The Crimson Star, the tale of Betelgeuse. In the velvet darkness of a winter night, high above the frost-kissed fields of Earth, a ruby-red star glimmers on the shoulder of Orion, the hunter. Its name is Betelgeuse, a celestial titan whose fiery glow has captivated humanity for millennia. Known to astronomers as Alpha Orionis, it is not the brightest star in its constellation. That honor belongs to Rigel, a dazzling blue-white beacon. But Betelgeuse commands attention with its sheer size, its ruddy hue, and its unpredictable nature. For centuries, stargazers have watched this cosmic giant, whispering tales of its power and mystery. But in the winter of 2019, Betelgeuse began to behave in ways that startled even the most seasoned astronomers, dimming dramatically as if signaling its final act. Was this the prelude to a supernova, an explosion so grand it could outshine the full moon? Or was it merely another chapter in the star's enigmatic story? This is a tale of Betelgeuse, a star on the brink of cosmic cataclysm, and the humans who strive to unravel its secrets before its inevitable end. Chapter 1. The Red Giant's Glow. Long before telescopes pierced the heavens, ancient eyes turned skyward to Orion, the mighty hunter striding across the night. On his upper right shoulder, a star burned with a distinctive crimson glow. The Arabs called it Yad al-Jawza, the armpit of the giant, a name that would evolve into Betelgeuse. To the ancient Chinese, it appeared yellow, a clue to its earlier life as a yellow supergiant. The Greek astronomer Ptolemy, peering at it in the 2nd century, described its color as ruddy, a hue that hinted at its advanced age. Betelgeuse was no ordinary star. It was a red supergiant, a behemoth nearing the end of its life. Betelgeuse is vast, so immense that if it sat at the center of our solar system, its outer layers would swallow Mercury, Venus, Earth, and Mars, stretching nearly to Jupiter. Its diameter, though difficult to measure precisely due to its pulsating nature, is estimated to be 700 times that of our Sun. Yet, for all its grandeur, Betelgeuse is a star in decline, burning through its fuel at a prodigious rate. While our Sun has billions of years left to shine, Betelgeuse's lifespan is measured in mere millions, a fleeting existence for a star of such magnitude. At its core, Betelgeuse is a furnace of unimaginable power. Hydrogen atoms, crushed by immense gravity, fuse into helium, releasing the light and heat that make the star glow. But Betelgeuse has long since exhausted its hydrogen reserves. Now, it fuses helium into carbon, and as each fuel source dwindles, it moves to heavier elements, neon, oxygen, and eventually iron. Unlike lighter elements, iron fusion consumes energy rather than releasing it. When Betelgeuse's core fills with iron, it will no longer be able to support its own massive weight. The star will collapse in a fraction of a second, triggering a supernova, a cosmic explosion that will release more energy in moments than our Sun will emit in its entire 10-billion-year life. Chapter 2. The Great Dimming. In late 2019, something extraordinary happened. Betelgeuse, the 10th brightest star in the night sky, began to fade. For centuries, it had been a reliable beacon, visible even to the naked eye from North America, Europe, and Canada. But now its brilliance waned, dropping from a magnitude of 0.5 to a dim 1.7 by February 2020. Astronomers and backyard stargazers alike turned their telescopes toward Orion's shoulder, their hearts racing with a mix of awe and apprehension. Was this the moment Betelgeuse would erupt into a supernova, a spectacle not seen in our galaxy since 1604? Dr. Elena Marquez, an astrophysicist at a mountaintop observatory in Chile, was among those captivated by the star's behavior. She had studied Betelgeuse for years, drawn to its erratic cycles of brightening and dimming. Every 5 years or so, the star pulsed, its outer layers expanding and contracting over a 100-day cycle, shifting its diameter and temperature. But this dimming was different, deeper, more prolonged, and utterly mysterious. It was as if Betelgeuse was pulling a cosmic curtain across itself, Elena said, her eyes fixed on the data streaming from the Very Large Telescope, VLT. The astronomical community buzzed with theories. Some speculated that Betelgeuse was on the verge of collapse, its core teetering on the edge of catastrophe. Others proposed a more mundane explanation. Perhaps a massive cloud of stellar dust, ejected by the star itself, had drifted into our line of sight, blocking its light. Elena and her team pored over images from a Hubble Space Telescope and ground-based interferometers, searching for clues. What they found was astonishing. Betelgeuse had unleashed a surface mass ejection, SME, a colossal outburst of material 400 billion times larger than a typical solar coronal mass ejection. This plume, stretching 30 astronomical units, 30 times the distance from Earth to Sun, was one of several ejections detected around the star. The ejected material formed a nebula around Betelgeuse, a glowing shroud 250 times larger than the star itself. This nebula, composed of gas and dust, absorbed and scattered the star's light, contributing to the dimming. By mid-February 2020, Betelgeuse's brightness stabilized, and by February 24th, it showed no significant changes in its infrared emissions, ruling out an imminent core collapse. The star had not died. It had merely thrown a tantrum, casting off part of its outer layers in a dramatic display of stellar unrest. Chapter 3. A Star on the Move. Betelgeuse is not a static fixture in the cosmos. It hurtles through the interstellar medium at 30 kilometers per second, a runaway star ejected long ago from the Orion OB1 Association, a stellar nursery that includes the stars of Orion's belt. As it moves, Betelgeuse carves a shock arc through space, a glowing wake that stretches over 4 light years. This arc, visible through powerful telescopes, is a testament to the star's restless journey. Measuring Betelgeuse is no easy task. As a pulsating star, its size fluctuates, sometimes by as much as 35% depending on the wavelength of light used to observe it. Its outer layers, roiled by massive convective cells, giant bubbles of plasma rising and falling, create patterns that shift over weeks or months. These cells, combined with the star's slow, uneven rotation, make its surface a chaotic landscape of light and shadow. The circumstellar envelope, a cloud of ejected material, further complicates observations, absorbing and emitting light in ways that alter the star's appearance. In July 2009, the European Southern Observatory's VLT interferometer captured images of a massive plume of gas erupting from Betelgeuse, one of at least 6 such ejections recorded. These outbursts, comparable in scale to the distance between the Sun and Neptune, hinted at the star's instability. Each ejection shed roughly 1 solar mass every 10,000 years, enriching the surrounding space with heavy elements. These materials, carbon, oxygen, and eventually iron, would one day seed new stars and planets, continuing the cosmic cycle of creation and destruction. Chapter 4. The Ticking Time Bomb. By 2025, Betelgeuse had returned to its normal brightness, but its irregular dimming cycles kept astronomers like Elena on edge. The James Webb Space Telescope, Hubble, and ground-based observatories like ALMA tracked every fluctuation in the star's photosphere, the layer from which its light emanates. These observations revealed a star in turmoil, its surface roiling with convective cells that spanned vast portions of its diameter. Each pulse, each ejection, offered clues to the star's internal processes, but the ultimate question remained: when would Betelgeuse explode? The timeline of Betelgeuse's supernova is maddeningly uncertain. It could happen tomorrow, next year, or in 100,000 years. Some simulations suggest the star is already fusing silicon, the final stage before iron accumulates and triggers collapse. Others argue it has millennia left to burn. The margin of error in these models is vast, as the physics of massive stars is fraught with complexity. Betelgeuse's slow, uneven rotation and its chaotic mass ejections only add to the challenge of predicting its fate. Yet, the prospect of supernova is not a cause for fear, but for wonder. At 640 light-years away, Betelgeuse is too distant to harm Earth. Its explosion will be a spectacle unlike any in recorded history, outshining the full moon and visible even in daylight for weeks or months. The energy released in those fleeting moments will dwarf the sun's entire output over its 10-billion-year life. Neutrinos, gravitational waves, and electromagnetic radiation will flood the cosmos, offering a treasure trove of data for scientists. Elena and her colleagues have prepared for this moment. Telescopes worldwide are equipped with protocols to detect the first signs of collapse, a sudden spike in neutrinos, a flicker in brightness, or a shift in the star spectrum. The supernova will be a natural laboratory, allowing astronomers to study stellar death in unprecedented detail. Betelgeuse is our window into the universe's past and future. Elena said, her voice tinged with awe. It's a reminder that even stars in their death give life to the cosmos. Chapter 5, The Cosmic Legacy. Betelgeuse is more than a star. It is a storyteller, weaving a narrative of creation, destruction, and renewal. Its ejections enrich the interstellar medium with the building blocks of life. Carbon, oxygen, iron, and perhaps even gold. When it finally explodes, it will scatter these elements across space, seeding future stars and planets. The supernova's shockwave may trigger the collapse of nearby gas clouds, sparking the birth of new stellar systems. In its death, Betelgeuse will ensure the universe's ongoing cycle of creation. For now, Betelgeuse remains a celestial enigma, its pulses and outbursts a puzzle for astronomers to solve. Each observation brings humanity closer to understanding the life cycles of massive stars, the chemical enrichment of galaxies, and the origins of the elements that make up our world. The star's proximity, closer than most supernovae we observe, makes it an ideal subject for study. With instruments growing ever more precise, scientists can now detect minute changes in Betelgeuse's photosphere, offering glimpses into processes that will culminate in its explosive end. As Elena stood beneath the Chilean sky, her telescope trained on Orion, she felt a connection to the countless generations who had gazed at Betelgeuse before her. From Ptolemy's ruddy star to the Chinese astronomer's yellow giant, from the Arab scholars who named it to modern scientists who track its every pulse, Betelgeuse has been a constant presence in humanity's story. Its supernova, whenever it comes, will be a moment of unity, a cosmic event that will captivate the world, from amateur stargazers to astrophysicists. Epilogue, awaiting the light. Betelgeuse continues to pulse, dim, and brighten, a stellar time bomb ticking in the night sky. Its story is far from over, and humanity watches with bated breath, eager to witness its final act. Whether it explodes tomorrow or in a distant future, Betelgeuse will leave an indelible mark on the cosmos and on those who study it. It is a reminder of our place in the universe, small yet curious, fleeting yet determined to understand the stars. For Elena, Betelgeuse is more than a scientific puzzle. It is a symbol of the universe's beauty and impermanence. We may never know exactly when it will happen, she said, her eyes reflecting the star's crimson glow. But when Betelgeuse goes supernova, it will light up the sky and our minds, showing us just how magnificent the universe can be. And so, the red giant shines on, a beacon of mystery and wonder, waiting to tell its final tale in a blaze of cosmic glory. Its nebula and altered its brightness. The data from ALMA revealed intricate details. Tendrils of gas stretching across light years, clumps of dust scattering infrared light, and shock waves rippling to the interstellar medium. It's like Betelgeuse is breathing. Arjun told Elena during a virtual conference call, his screen glowing with spectral maps. Every pulse, every outburst, tells us something about what's happening inside. The collaboration between Elena and Arjun was part of a global effort to piece together Betelgeuse's story. While Elena's optical observations tracked the star's surface activity, Arjun's radio data revealed the dynamics of its outer layers. Together, they hoped to unravel the mystery of the 2019 dimming and predict what might come next. The great dimming, they now believed, was caused by a massive dust cloud formed during a surface mass ejection, a theory supported by images from the James Webb Space Telescope. These images showed a turbulent photosphere, with convective cells the size of solar systems churning beneath the star's surface. But the question lingered. Was this a sign of Betelgeuse's final days, or just another chapter in its restless life? Chapter 7. Echoes of the past Betelgeuse story was not just a tale of the present, but a bridge to the past. Its origins lay in the Orion OB1 Association, a stellar nursery where massive stars were born in a frenzy of heat and gravity. Ejected from this cradle, Betelgeuse had wandered the galaxy for millions of years, leaving a trail of ionized gas in its wake. Ancient astronomers, from Ptolemy to the Chinese stargazers of the Han Dynasty, had noted its changing colors, yellow in one era, ruddy in another, hinting at its evolution from a hot, blue star to the bloated red supergiant it is today. Arjun often thought of these ancient observers as he pored over his data. Their records, etched in scrolls and stone, were the first threads in the tapestry of Betelgeuse's history. Modern technology had woven new threads, revealing details they could scarcely imagine. Interferometric techniques, like those used by the VLT, allowed astronomers to measure the star's diameter with unprecedented precision, despite its pulsating nature. In 2009, images had captured a plume of gas erupting from Betelgeuse, a spectacle that stretched as far as Neptune's orbit in our solar system. These ejections, our June realized, were not random. They were the star's way of shedding its outer layers, preparing for its final act. The circumstellar envelope, glowing faintly in infrared, was a treasure trove of information. It contained heavy elements forged in Betelgeuse's core, carbon, oxygen, neon, that would one day enrich the galaxy. Our June's ALMA observations showed how these materials interacted with the